Hi, in this video we're going to step through some of the exercises in Unit 3.2. In the previous video we got through the checkpoints for 3.2.1, and here we're using those skills and applying them to these exercises. So first let's go look at the sun and moon. As you click around on the blue part, the sky, we'll notice that the sun appears to follow our mouse Y location, as well as the mouse X. Pretty straightforward. I think we know how to do that. But what's more interesting is what's happening here on the bottom. But as you click further and further down towards the edge of the blue and the black line, you'll notice that something happens. So we're at a Y value here of 179. And if I click lower than that, so if I click anywhere in the black for sure, nothing happens. If I click right at the edge, nothing happens. So the first place that I can see something happen is when our mouse value is right there. So 179, the actual value is, well, I think it's 180. So the question is, what's going on here? How do we create this effect on the screen? So first, notice that our circle has a radius of 20. Both of them do, right? So these circles have the same size. Now you have to do a little thinking here. If our radius is 20 and this barrier between black and blue is at about 180, that would make sense that we can't create a circle whose center is more than 180. In other words, our yellow sun is never allowed to go below the transition between blue and black. So at any point along here, when I click on the sky, the x coordinates of these yellow and white circles are identical. So that's easy to match. And really only the question here is, what's the y value of this white circle? And this is the trick, and I'll just reveal it to you. These are mirrors. So if, for example, this yellow circle has a y value of 150, the mirror means that we're going to subtract 150 from 400 to get 250. So the point is, at all times, these two numbers, the y values, add up to 400. 400 is the total height here. So this is just some algebraic thinking. If the whole is 400, and this part here from the top down is 150, we want this to be a mirror, then we subtract 400 minus 150 gives us 250. So the second part of this is to figure out, well, we can write this code for sure, and then we'll make it conditional on where the mouse is. So in other words, we only want this action that we're seeing right now to happen if we click somewhere above the transition point. Well, let's get coding here. They give us a whole bunch of code to start with and some instructions on what to type here. So here on lines 34 and 35, this is now part of the on-mouse press. So we're inside the function. When you press the mouse, these lines with the pound signs in front of them are all comments, and everything is indented 4 spaces. So the first thing that happens when you click the mouse is that we'll change the center of the mouse, of the yellow sun, the circle, to the current location of mouse X and mouse Y. So that's a beginning point. We can run this program and see what happens at every stage. So at this current stage, we get an error on line 34. And that's because, we kind of got excited and went right down to the bottom and didn't actually look up above. They didn't complete the code for the sun and the moon, so they left it up to us to provide the details for those variable labels. So we can do that. So first, just to remind you that Python commands need to start on the left margin. So we'll get rid of those comments and move that all to the left. And so we can go look at the inspector now and just go see, what is this thing? So we've got a circle of radius 20 with a gold color, and its center is at 100, 100. So the code for that would look like that. Likewise for the moon, it's the same exact thing. Its starting location is slightly different, and it's got a different color. but it's the same process. Use the inspector to define those parameters and plug them in. So now, when later we want to change these 2 points, we're going to refer to those as center X and center Y. It should work. So let's run this, and again, we're just, wherever we click, the sun follows, right? And at this point, we haven't restricted where the center of that yellow circle can be. So we're not done yet, but it's a good starting point. Well, likewise, I think we also have to write the code for the moon. So we could start that off the same way. Moon.center X is equal to mouse X, and moon.center Y is equal to mouse Y. Now, we know this isn't quite correct. We need to adjust it. But once again, it's a good starting point. So we've got the sun and the moon going to the same place. Well, that's not the intention. So this is where we now need to use that idea of the mirror. So instead of putting the moon at the same vertical value, this is the reflection, or the mirror part of it. So as I explained before, that's the 400 minus mouse Y. So if we run this now, we have that effect, no problem. But the one thing we now have to fix is that as I click further and further down, we see those things switching places. And in the solution, we're not allowed to have the sun go below into the black regions. So we need to place some conditions on this code. When we were playing with this, we noticed that we could never get that yellow circle to have a center beyond 180. In fact, it had to be less than 180. So what we're going to do now is make all of this code conditional on the result of an if statement. So step 1, I indented it. So now the single line of code in this function is just going to be an if statement. And what we're testing is if the mouse Y value is less than 180. So a Y value less than 180 means that you're going to be above that black line. Don't forget the colon. So with that simple change, just indenting the 4 lines of code and making them part of an if statement, I think we get the effect that we're looking for. As we get closer and closer, all right, we see that that worked. So on to the next problem. So this one's kind of fun. Once again, just make sure and read all the statements here, because sometimes those give you clues. When you click your mouse on the canvas, his belly's going to grow, and if you keep clicking, we're going to get a message that pops up. So maybe let's count our clicks, and maybe that will help us determine what we should be doing. So I'm just clicking anywhere on the canvas, once, twice, 3 times, 4 times, 5 times, 6 times, 7, 8, 9, 10. Oh, on the 11th click, we got this thing to pop up. All right, so that should be something we can test for. We're just testing to see either how many clicks we've made or possibly how big this circle is. So let's go run this again and just be a little bit more like a detective here. I'm running the inspector. So this is the starting point. Inspector is on. The radius of that circle is 70. You can see it in the upper right corner. So as I click, now it's 73, 76, 79, 82, 85, 88. We're adding 3 each time to the radius. 91, 94, 97, 100. Aha. At 103, the message came up. So we could either count clicks, which we haven't learned how to do yet, or we can just monitor the size of this circle. And it would appear that as soon as the circle got larger than a radius of 100, that's when the message popped up. So when we say the message popped up, all we're talking about is the visibility of this label. It was previously visible set to false, And all we're going to do now, our plan for this program, is to increase the size of the circle every time we click it. And at any given time, if the radius is bigger than 100, we'll just pop this message up. That doesn't mean the program stops running. Every time you click, we still get a bigger and bigger circle there. But that's kind of weird, isn't it? All right, let's code this thing up. I think the first thing to notice is that in our mouse press, we need to bump up that radius by 3. So that's the very first step. And the second step then would be to check the status of the radius, and if it's bigger than 100, then turn the visibility on. And that's exactly what this line of code does. All right, just make sure you understand this is the test, and when it's true, then we'll execute the single line of code in this if statement. So we'll run this and check it, and there we go. So I'd like to move on now to the scoreboard problem. By the way, the fireworks problem is pretty straightforward. It's very much like the earlier exercises. So first, notice that this one's a little different. There is no solution here that you can see by clicking on the screen. So all we're doing in this program is calling the function to update the scoreboard. So you have to send in the score of a game. So when we look at these test cases, the current test case is running. So the home team had a score of 49. The away team had a score of 38. So let's just examine what we see on the screen. First of all, the timer here is just a prop. It's not doing anything. But the home score appears. They won, they're green, and the away team lost. So we bumped up the number of wins for the home team. In the second test case, again, we reset everything, so it starts at 0. So let me rephrase that. This is not cumulative. Anything that happened in test case 1 is invisible. We start all over again with test case 2. So in test case 2, we're playing 2 games. So the home team won on the first game and the second game. So let's run that. 2 wins, and it's just showing the most recent score. All right. Let's try this for test case 3. There's a home team wins, and wins. So we should see 3 wins. All right, so there's more test cases. Let's explore those. This case, the home team is going to lose. So notice what happens. We bump up the loss column by 1, and the away team window goes green. Likewise, the away team won both games, so they have 2 wins, but that means the home team has 2 losses. Remember, this scoreboard is relative to home, right? A win for the away is a loss for home. All right, I think we see what's going on here, right? So we have a win for the first game here and a loss for the second. So tie for wins and losses. But the one that's green is the most recent win. So apparently every time you win a game, we're going to update the wins and losses, and we're going to make your scoreboard be green. That provides us with an idea, or at least a starting point for our code, which we'll get to right now. So I've gone ahead and written some code here. The first part was to just follow the instruction to dump those current scores into the home score label and the away score label. That part's easy. And then in the second part of the function, I've written what we call pseudocode. It's a plan for what we need to do based on the discussion that we just had. So in the case that the home score wins, we're going to bump up their label and turn their score to green and the opponent's to red. Otherwise, we're going to do the reverse. Increment the losses and set the home team to red and the away team to green. So to save time, instead of having you watch me replace this with real code, there's the real code. So the Python code here just implements what we were planning to do based on our observation and discussion. And we should now have a running program. So back up this video, pause and play, and just examine and study until you understand the whole process.